Okay, so what we're going to be looking at now is that we're going to be moving on and we're going to be taking these functions that we have and we're going to be putting multiple functions on the same graph. And then we're going to graph them and see where they intersect, or even if they do intersect. Okay, and what these are called system of equations. And the system of equations is a set of different equations of two or more equations that have the same variables. So they appear on the same graph. And what we're going to first start off with is that we're going to graph these and then find what their answers are. Okay. So a linear system is one where there's only two different variables, which is what we're going to be dealing with mostly for this first half. A little bit later we'll go into three variable, but to start we're just going to start with two. And this would be an example. As you see, it's got a little bracket here. It's saying that both of these are contained in one. And you've got y equals 3x plus 2 and y equals negative 4x minus 6. Okay. Now what we're asked to do here is we're trying to find what point or what x and y values can we plug in there to make this statement true so that both of those agree with each other. And one way that we're going to start off with doing it is that we're going to be graphing both of these, and then we're going to see where they intersect. So the first thing you're going to have to do is you're going to have to make this into a function that you can graph. Which, again, the easiest one for us to graph was the slope-intercept form. So we're trying to get y by itself. So in this case, you would add x to both sides, and then you would divide by 3. And then the second one, the blue one, I would move the y to the other side, and then move the 8 to the other side. So then you'll have the first one should be like y equals 1/3 x plus 2, and the second one should be y equals 2x minus 8. And now we'll graph both of these. So there's your intercept, 2 and negative 8. Okay, for the 2 you're going to go up 1, and you're going to go right 3. And then the second one you're going to go up 2 and right 1. Okay, and then you'll see where they cross. So as you see here, this is where they intersect. Okay. And then your answer is that point. Okay, so your answer in this one would be 6, 4. That would be your answer to this. So when you plug in a 6 for the x, and you plug in a 4, so if you plug in a 6 here and a 4 here, that agrees with the statement. Negative 6 plus 12 equals 6. That's true. And then when you plug it into the second one, 12 minus 4 is equal to 8. Okay, so as you see, they both work, and that's what we're trying to find. Now, these are applications in, like if you want to find, okay, this is how much it's going to cost, this is how much we're going to make, and you want to see where you can maximize. And we're going to actually talk about this in a couple sections. And we're just going to be doing different applications of this process. But first, we're going to have to find different ways of solving these. First one we're going over is graphing. All right, so now like this one right here, first thing you want to do is move everything to the other side so you get y by itself. Okay, so it looks like you'll get y equals negative 3x plus 3 and y equals 2x minus 7. So you'll start at 3 and then you'll go down 3 and right 1, and then the other one you're going to start at negative 7 and you're going to go up 2 and right 1. And then you graph both of those. And as you see, there's our intersection. And then that would be our answer. Okay, wherever that coordinate is, 2, 3. Now, what you probably want to get is graph paper for these so that you can estimate where it is exactly. For graphing, you're going to estimate approximately where you think they intersect. Okay, because we don't have too in depth with our graph paper to be able to pinpoint stuff exactly. So you'll estimate what it would be. All right, independent, dependent, and inconsistent. So with these functions, when you have these, they fall into three different categories. They could be independent, dependent, or inconsistent. Independent functions are functions that intersect each other, so they cross. Okay, and as you see, the first check to see if it falls into one of these categories is you check their slope. If they have a different slope, it's automatically independent. Okay, so if they have different slopes, they're independent. Okay, different slopes, independent. Now, if they have the same slope. They can either be parallel or they could be the exact same line. A dependent set of lines are lines that are exactly the same. If you were to reduce both of them to their simplest form, they are exactly the same. And inconsistent means that they're parallel and they'll never intersect. So once you know that the slope is the same, you go into the second check, and the second check is the y-intercept. So if the y-intercepts are exactly the same and the slope is exactly the same, right, they are dependent. They are the exact same line. If something has the same slope and they intersect at the same point, then they are the same line. Now, if they have a different y-intercept, which means they have the same slope, but they're just kind of off of each other, they're parallel. They'll never intersect, so there would be no answer. Okay? Inconsistent have no answers. They never intersect. Independent have an infinite number of answers because any point along that line will work. And then independent has exactly one. Okay? So that's independent, dependent, and inconsistent. So when you're looking at these, this first one, what you want to do is you want to set these equal. So set them equal to y so you can identify the slope and the intercept. So this first one will be negative 3x plus 5, and the next one would be y equals negative 3x plus 2/5. Same slope, so it's not independent. Different intercept, so that means it must be inconsistent. Okay, so those are different, so it's inconsistent. Now you go to the next one. If we move the x to the other side and then we divide by 2, we end up getting y is equal to 2x plus 3. Okay, so if you were to solve this one for y, you get exactly the same. As you see, they're the exact same, so that means they are dependent. They're the exact same. Dependent. They're dependent on each other. And then the last one, when we solve for y, we get y equals x minus 5 and y equals 2x minus 3. Different slopes means they're independent. Okay? All right, so independent, dependent, inconsistent. All right, your IRAT. What you're going to do is that the first one you're going to graph and find what it is. Again, estimate if it doesn't come up as a nice round number. Okay, so estimate what the answer would be. And then the last two, identify if it's independent, dependent, or inconsistent. So again, different slopes, independent. Same slope and same intercept, dependent. Same slope, different intercepts, inconsistent. Okay, so find those and just label which one of these each of them are. Okay, so that's it, and that's the first section.